Good morning, guys. Thanks, Gina, for helping me with that, and Lamont for getting in. If you can pass the word along to your first period friends, that'd be great. I'm gonna check my email and see if anybody else is trying to join us. Give me a minute. All right, what we're going to start with today is I want to show some of the work that you guys did in the last week for the Enter to Win $250,000. So before I start, what I'm going to ask you to do is to please write your ID numbers in the chat box. All right, thanks, Lamont. Thanks, Gina. All right, go ahead and write your ID number in the chat box, Chris. Thanks for joining us. All right, and good morning, Ayana. Can you also please put your ID number in? Okay, thanks, Gina. Ayana, I need you to put your ID number in, please. And I think Anton is going to be joining us. You guys can pass the word along about the ID if you had. Are you able to log in without the ID that I sent the girls? Thanks, Ayana. All right, I'm gonna keep allowing people to join for a while since there was some issues this morning. And I already sent Mr. Schofield an email to see if he can help us to figure that out. Hey, Gina. So let me start by sharing some of your work from last week because it was stellar. I was really impressed with all the presentations that you guys made. All right, so let's start with people that as Gina right here. So I'm going to start with this one.
Let's say so I experienced loss of a loved one or just lost a very serious relationship. It's possible. Some people put it up just stop. It's much more than that. It only gets.
All right, that sounds not very good because I recorded these. Let me do something else instead of showing them here. I'm going to show them using the actual just Canvas. I'll use Canvas. It'll probably have better sound. So All right, before I get into this, let me see if anybody else has joined us. And then after that, I won't worry about it as much. Okay, it looks like nobody's joining us. I will, because I gave Anton permission to perform his rap during the class. So if he does join us, he'll be the last one I allow to join. All right, thanks for being patient. Let's get busy here. So we don't have very many people here, so we'll just share some that are here. Okay, here's Ayana's.
Hello, my name is Ayana Duffley, and today I'm going to talk about COVID-19. Some of the causes of COVID-19 are: it is an infection with the new coronavirus, severe acute respiratory syndrome, coronavirus 2, or SARS-CoV-2, causes the coronavirus disease. Normally, a coronavirus our bodies are fevers, colds, shortness of breath, or difficulty breathing, tiredness, aches, runny noses, sore throat, headaches, diarrhea, and vomiting. And a very rare impact is loss of smell or taste. These symptoms can take up to coronavirus. Even though there is no approved solution, the suggestion is to stay at home and to only go out of your house when necessary. If you do suffer from the coronavirus, you should stay away from people and avoid human contact. On the other hand, if you are affected by the coronavirus, the mild and can be treated out. Virus, paracetamol, and plenty of fluids.
Camila, turn off your sound.
How the coronavirus is spreading. In conclusion, the coronavirus is a very serious, fast-spreading pandemic that kills over 5,000 people a day. This virus is nothing to joke about. Thank you.
All right, nice job, Ayana. See if I can get out of this. Oh, here it is. Okay. And Lamont, did you see what he had here? It was more of a PowerPoint. So he just gave some key you can do in order to prevent the passage of COVID-19. All right. Here's Maria's. This was really cute. Have you guys, any of you had a chance to look at each other since some of you are pretty close? I'm gonna take a minute to open. While we're waiting, if you'd like, you can go ahead and get into the new assignment for this week. It's called Sweat. And go ahead and open up this article and copy and paste the questions into a Google Doc while you're waiting, okay? Hope this doesn't take too long to open. While we're waiting, YouTube again, just in case. It might be worth it. The only thing that Maria's was amazing, like I said, for some reason the audio and visual components weren't completely synchronized. They weren't going together quite right. Okay, so what I'm going to do is I'm going to just move forward with this, Maria, to the YouTube channel. So I'm going to show that. If the sound isn't great, I apologize, but we can't wait for that to download. So let me go ahead and share this with you. All right, and here's Maria's right here.
Hey, I'm on the question and today we're going to talk about COVID-19. Well, during the whole all about that.
All right.
That's why we also said
So even though the sound isn't that great on here, it was great on her video. I want you guys to just pay attention to some of the visual aids that she used. They were really nice. So she's showing a syringe, and then she shows that the virus is inside the syringe. Which is great. Let me see what else I can show you from her visual aids. Kind of cute. So used a really lots of animated gestures in her face. Just made the video come alive, and then her gestures with her hands. Oh yeah. Thank you for that. All right. Chris joined us, so we can do one from Chris in a minute, as well as Gina's. Yeah. There's Chris's. All right. All right. Share that. His is loading a lot more quickly, so it'll just be a minute. Is there anybody else new? Oh, Camila's here. Oh, wait, we already have Camila in the meeting. One of these is not Camila then. Camila, the one that's already number in the chat box, please. Camila, did you do that for me? Okay, since we have two Camilas, I need you both to put yourselves on video so that I can see which one belongs and which one doesn't. Otherwise, I'm going to have to shut you both out of the meeting. Camila, put yourself on video. Thank you. And let me find this other one. This one needs to go. That's really weird. Put in waiting room. Ciao, Camila, second. All right. We're good to go. All right, let's listen to what Chris has to say. Sorry, I wanted to maximize that so it would be covering the screen. All right. Great job, Chris. Great visual aids and good presentation overall. I love all the little little animations you put in too. All right, and Gina will be next. Let's see. Hope he loves. Camila.
Let's say someone experienced the loss of a loved
Gina.
one, which has lost a very serious relationship. This can cause them to experience grief or deep sorrow. Some may put it as just being really sad, but it is much more than that. It all begins when you experience traumatic events such as a breakup and a neurological change occurs in your brain. A neurological change is when neurochemicals and hormones enter your brain. To be more specific, then, the limbic system and our prefrontal cortex. The limbic system is where we get our motivations, emotions, memories, and what we learn from. Our prefrontal cortex is where we get our senses and emotional behaviors. Now, through the 7 stages of grief, and they all have to do with the neurochemicals in your brain. For example, let's pretend Alice and Ben
Sorry.
have a relationship.
We'll watch this in a minute because
Alice gets really sad and starts to experience
it finally opened. Let me get this out of the
first
way.
stage is shock. Alice can't believe Ben actually broke up with her. In this stage, stress, acting as a stressor, causes the pituitary gland to make an adrenocorticotropic, ACTH, go into your adrenal gland. The adrenal gland then makes stress hormones that spread in your body. Then that leads to the second stage, which is denial. Alice gets a consistent feel of neuropenetrance together. The stage of denial is the defense mechanism that we have adopted so that we don't suffer and feel the pain all at once. Eventually, Alice will go into the next stage, the anger stage. Alice is angry at herself and feels guilty. Alice might experience loss of memory, no motivation, loss of appetite, overwhelming sadness and anger, and anxiety. It's also to do with the neurochemicals entering your limbic system and prefrontal cortex. Depending on the person, this stage can last a very long or a very short time. The neurochemicals will continue to the next few stages, which are bargaining and depression. During these 2 stages, people continue with the same symptoms. Amy might say, "Well, I want to talk to Ben more, so you're not going to help me." Bargaining leads to conflict, and what could happen if they did something different? Depression is the stage when they finally realize that there's no going back. Amy realizes that there's no way to be with Ben again, but she isn't completely over him yet. The symptoms can worsen in this stage, and if they don't receive help or move on to the next stage, it can have some serious consequences. Talking to a friend or family can help. A right study shows that in the depression stage, people can get body inflammation, which is when our body produces less white blood cells, so our immune system starts to swell. After this stage is over, the next stages are getting better. testing and acceptance. Alice tries to talk to other people to get better. She tests new ways to be happy. And in acceptance, Alice moves on. Alice is finally happy without Ben, but that doesn't mean she'll never be sad over him again. Maybe on his birthday she'll remember him, but she is done grieving. In order to get out of the depressive state, people do different things. Some people could talk to their loved ones, others do activities that make them happy. Everyone is different and everyone takes their own time to grieve and move on. People grieve in different ways and there are many other different stages of grieving. I'm Tina Staville and thank you for watching. Bye!
Beautiful work, Gina.
Let's say someone experienced the loss of a loved one or just lost a very serious relationship. This can cause some experience.
All right, so I think the one we have left of all the people who joined us today, I might have more, but is Camila's. Oh, hers must be in my email. So is there anybody else who would like to show their work today that I didn't? Camila, you want me to show your work? You want me to go into my email? Camila, you want me to show your work?
I don't believe it's fully submitted.
Oh, okay. All right, thanks. All right, so we're going to move on into today's assignment. Let's see. I was really pleased with those assignments, guys. You guys are your stars. Okay, so the assignment for this week is sweat. And as I mentioned, you need to click on this link. And when you click on the link, you're going to see the questions, okay? So you need to copy the questions into a Google Doc so you can be prepared to answer them, okay? I'm going to start by showing you this video. Can you see this? I don't think I shared this with you, did I? Let me make sure I'm on the right screen. Okay, so here's the video that goes along with this. I think that the first question is related to this, maybe the first two. So what can happen if you get too hot? Name 3 things that you can help to cool off on a hot day. And why is it a bad thing if you can't sweat? Let's see if we can answer those by watching the video.
For many, a day like today calls for one thing.
Just relaxing, soaking it all in. Hope it lasts another 6 months.
There's a reason they're called the lazy days of summer. Heat slows down the central nervous system, making us feel tired. And though many of us would take summer over winter any day, any extreme temperature is stressful to the body.
Annie, so I'm definitely a lot more sluggish, more fatigued. That's for sure. A little maybe short-tempered.
Extreme heat can throw our brain chemicals off balance and affect our mood. Blood pressure can also drop in the heat, which means your heart needs to work harder to make up for it.
If you're dehydrated, then you have less blood volume. So that will tend to bring the blood pressure down. And that's why, like we said, people might think or feel kind of tired or dizzy. That's because their blood pressure is getting low.
If that workout seems harder, that's because it is too hard and you could experience exertional heat stroke.
If you're running into problems with fluid balance or with electrolytes, then they can get muscle cramps. That's a common early sign of heat stress, particularly in people on exercise.
The flip side of exercising in the heat is that you'll have a harder workout.
You'll become fitter in terms of how much exercise you can do in the heat. And it does translate to a certain degree also to a non-hot part.
Whether you exercise in the heat or not, we all have one built-in adaptation after several days exposure to warmer temperatures.
What our body does is actually secrete more sweat, develop more what we call heat-activated sweat glands. And each one of those glands secretes more sweat as a result of the adaptations that occurs.
Of course, if you are going to exercise, keep hydrated. Drink long before your thirsty. Drink a lot afterwards to replace all the fluids that you've lost. Also protect your skin. It's your largest organ. With heavy sweating, the glands can clog up and get irritated. That can lead to a rash on your skin. If you have sunburn, the skin's damaged. You just can't let the sweat out properly. And that's your main method of cooling yourself. Meaning, you're just going to feel terrible.
So,
All right. So let's see if we can answer those first two questions. And please just voluntarily take off your mute if you would like to answer the question. What can happen if you get too hot? Name 3 things that can help you cool off on a hot day. All right, first of all, let's start with the first part. What can happen if you get too hot? You're gonna get what? Starts with the D. Dehydrated, okay? You'll get dehydrated as a result. So you can feel tired, get dizzy, or even faint. Your heart will have to work harder, and you could experience heart attack or stroke. Muscles can cramp due to loss of electrolytes through sweating. Sweating is good though. Sweat is a liquid that allows your body to cool as it evaporates. So if you sweat, you need to replace your liquids. Let me go ahead and share this. I have my answers already written down, and I'm going to share some of these answers with you. So sweat is a liquid that allows your body to cool as it evaporates. So if you sweat, you need to replace liquids by drinking water and or Gatorade or other drinks with electrolytes. You should stop overexerting yourself by lying down and cooling your body with a cold bath or if you become dehydrated. Okay, you don't want to experience heat stroke or anything that could cause you to, hurt your body or even die. So you need to make sure that you stay properly hydrated and cooled in the hot summer months. Okay, so make sure you answer that question. And then the second question under before reading says, why is it a bad thing if you can't sweat? Well, sweating is your body's cooling system, and if you're not sweating, it won't work and you would overheat. All right, so go ahead now and open the article that we're reading today. And I want to share the article. Here it is. Okay. So we're going to take turns reading through here and answering the questions. The next question that you need to answer is number 3 or number 1. It's the first reading question. Why does Yana Kambarov smile when she sees her twins begin to sweat? Okay, I'm going to start and then you guys can take turns reading, all right? In the sticky, muggy heat of summer, it seems like every movement can make you sweat. As beads of salty water appear on your forehead and your shirt starts to stick to your back, you might run to find the nearest air-conditioned room. But when Yana Kambarov's 3-year-old twins begin to sweat, she just smiles. I like sweat, she explains. Kambarov works at the University of Pennsylvania in Philadelphia. As an evolutionary biologist, she studies how animals evolved over time. And when she sees her kids sweat, she knows that they are activating a trait humans evolved to keep from overheating. You're built for this, she says. The reason you don't overheat and die is because your sweat glands activate to cool off. So she's happy when she sees her kids sweat because she knows that they are using something to keep from overheating. Make sure you answer the first question for the reading. All right, Camila, you want to continue?
We're on sticking up for a sweat.
Right here, to anyone.
Oh, okay. To anyone trapped in a crowded space filled with stinking, sweaty people, Kambarov's enthusiasm might seem a bit bizarre, but she's not alone. Sweat fascinates scientists the world over.
Continue.
Do I keep going?
Yes.
Some, such as Kambarov, want to know where we got our sweaty skin. Others are trying to put our natural strength to good use. They're out to track your health and even catch a killer or two.
Okay, to catch killers. Let's see how that comes into this. Maria, you want to continue sticking up for sweat?
Okay. So Kambarov didn't always have such an appreciation for perspiration. As a teen, she wanted to be an archaeologist, someone who studies human history. I have always liked history. She explains, I like to know where things come from. But when she took a class on archaeology in college, the shine wore off. I didn't want to chip stone in the desert somewhere, she says. It's just not me.
Keep going.
Okay, instead, Canberra realized she was, how you say this?
Fascinated?
Fascinated with the history of humans as a species. She wanted to combine her love of biology, studying living things, with anthropology, the study of human culture. Her ultimate goal was to find out how humans as a species come to be.
All right, good job. Thank you. Lamont, continue, please.
Part of what makes our species what it is today. She soon realized is how people look. We stick out like a sore thumb among primates, she said. Humans are often called the naked ape. Even the hairiest people lack the thick mat of fur seen on apes, such as chimpanzees and gorillas. We have hair and plenty of it, but the strands are thin. That leaves our skin exposed and covered in sweat glands.
Okay, excellent. You can continue reading in a second, but I just want to point out for number 2, you're going to have to write down the 3 types of glands found on human skin and what they do, and that's what he's going to read about now. Continue.
3 types of glands dot on our skin. They release secretions onto the surface. Sebaceous glands appear mostly on our face and scalp. They put out oily chemicals and moisturize the skin and hair. They also help waterproof the skin. A type of sweat gland known as apocrine cover our armpits and genital regions. These glands secrete a thick substance full of fat. Bacteria feed on those fats, at the same time producing the smell we lovingly call body odor.
Okay, thank you. Ayana?
But what is that? Eccrine?
Uh-huh.
Glands dominate most of our skin's real estate. They produce the watery, salty sweat that helps the skin cool off. These glands show up everywhere from your feet to your scalp and appear as neighbors to those sebaceous glands on your face and the apocrine glands in your armpits and genitals. The only place people don't have eccrine sweat glands are on the skin of their lips and nipples.
Okay, good. One more paragraph. Ayana, can you read it, this paragraph too?
Yeah.
Thank you.
Yeah. Yes. And wow, can humans pump out a sweat? Even when relaxing at home, people produce about 500 milliliters, just over 2 cups of sweat per day. But when working out in the heat, people can pump out up to 10 liters, 2.6 gallons of this stuff. Our mechanism for cooling ourselves off is to sweat. Kambarov explains, in order to do that, we have an enormous abundance of sweat glands.
Good. All right, Chris, continue.
Those sweat glands are connected to nerves. The nerves are controlled by a part of the brain called the hypothalamus.
Hypo,
It,
hypothalamus.
it's at the base of the brain, hypothalamus. It sits at the base of the brain, roughly behind the bridge of the nose. It senses when our body temperature is rising, such as when we exercise or step outside on a hot day. When the heat is on, the hypothalamus signals our endocrine glands to rev up.
Keep going.
As they spring into action, they suck water and salt from the spaces between our cells. The liquid collects in the gland, pumps there will force out most of the salt. The remaining watery solution squirts onto the surface of our skin. There, wind and air evaporates the sweat along the way, removing some of the body's heat.
Great job. All right, Gina.
Humans certainly sweat a lot, but we don't sweat alone. In fact, Kamarov notes sweat is a mammalian trait. Other key mammal traits include fur or hair and nursing infants with milk. And while all
Ancestral. You there, Gina? Gina, I've lost your audio, so we're going to come back to you. I'll continue, okay? And while all ancestral mammals could sweat, some modern animals have lost the trait. Among them are pigs and whales. Why dump water when you're surrounded by it, after all? You don't see other mammals wiping their sweaty brows because most mammals' sweat glands are concentrated on the palms of their hands and the soles of their feet. Even mice have sweat glands on their palms and soles. This seems like an inconvenient place to release slippery sweat. In fact, sweat helps mammals get a grip. Okay, so going back to the questions, how does sweat help to limit overheating? You should be able to answer that, as well as we already went over what are two key mammal traits like fur and mammary glands. All right, we're going to get ready to answer these next questions. While I read now, I want you guys to fill in the blanks where I pause. Okay, so everybody pay attention and take yourselves off mute and participate. All right, we're starting here at the top of the page where it says move. Move a dry hand across the tabletop. It slides easily, Kambarov observes. However, she notes, if you have
Sweat.
on your hands, it
Sweat.
still starts to suction. Just like wetting a suction cup helps it to stick onto the wall inside your shower, a little water helps hands and feet grip. Humans have far more endocrine
Glands.
and in animals. Scientists suspect with our hairlessness, Kambarov says. The less hair you have, the more skin space there is for sweat glands. And bare skin means that sweat can evaporate and
Cool.
better than if the water gets trapped by fur. Kambarov wants to know how humans ended up with hair instead of fur and oh, so many sweat glands. To find out, she compared skin from humans, chimpanzees, and a type of monkey called the rhesus macaque. Not many people would willingly donate skin for science, so Kambarov worked with
Cadavers.
cadavers, human corpses. That was actually the easiest part. She also worked at Harvard University in Cambridge, Massachusetts, animals. But she had to be patient, waiting for animals to pass on. Every time a monkey died, we'd get an email and a package in the mail, she recalls. Chimps were even more difficult. In the end, Kambarov got those samples from specimens that had been stuffed and preserved for museums. Samples in hand, Kambarov carefully counting hair follicles and sweat glands. It turns out that people, even if we don't look like it. lost? What did I highlight here? Can you see that?
Fur.
Fur. But we haven't lost.
Hair.
Good. Kambarov explains, we have as many follicles as a chimpanzee. It's just that the follicles are tiny. Tiny follicles produce much finer hairs, and this leaves more skin surface on which sweat can spread out. Now you can sweat and evaporate very efficiently, she says. It makes sense, Kambarov explains, if you're going to adopt sweating to cool off as opposed to panting. Her team published its findings on November 7th, 2018 in the Journal of Human Evolution. So how did Kambarov get her samples of monkey and chimpanzee skin? Lamont,
Yes,
how did Kambarov get her samples?
I forgot.
The monkey and chimpanzees, guys. The skin. How could she get skin from a monkey or chimpanzee? What would they have to do first?
She had to wait for them to die.
Yeah, she had to wait for them to die. So she got them from, I think they said the University of Harvard in Cambridge, Massachusetts. She got the samples from them. And the other question says, why is sweat a good substance to monitor when looking for signs of disease? Let's see if we can find out the answer to that. Like a little mystery here we got to solve. Oops, wrong one. It's this one. All right, Camila, can you continue reading right here where it says long ago at the top?
Long ago, our bodies took up precipitate. I apologize. What was it?
Perspiration.
Perspiration as a damp but useful tool. Now science is finding new uses for our sweat. Keep going. Sweaty sensors. Sweat glands suck, literally. Sweat comes from the water that's in and between your tissues, Kambarov explains. When the glands become active, they pull that
interstitial
fluid between the tissues into the gland, and that includes drawing up fluid from the tiny blood vessels running near your skin.
Okay, one more.
All of that fluid enters the sweat glands, and it includes far more than water. There are salts, of course, but this fluid also can include any other small chemicals that had been in the blood and tissue. Once in the sweat glands, this liquid triggers tiny pumps. They pull out much of the salt, but some remains behind. So will some share of other chemicals. All of these now get ejected out of the skin along with the sweat.
Great.
Along with the sweat.
Lamont, read here.
For Geo, well,
Weigao, I guess. I don't know. Weigao.
For Weigao, sweat is just the messenger. It's those extra chemicals that interest him. Gao is a medical engineer someone who designs and develops solutions for medical problems. He works at California Institute of Technology in Pasadena. Keep going?
Yes.
Gao is hoping to use sweat to help people receive medical care tailored to their needs. It's a concept known as personalization medicine. He's especially driven to find when people become sick long before they may feel the first symptom.
Great job. All right. Chris.
Geocurrent. Oh wait, is it geo? No.
The top.
Okay. I got town in China. He said there's many people who didn't realize they were sick until it was too late. Jonah. After his grandmother had a stroke, it took him a while to get home. By the time he did, he recalls she didn't remember me. If his family had known she was at risk for a stroke, he said they might be able to help her. Geo now developed devices called sensors to pick up data from body. He's currently on consent when study people for signs of disease, they tend to analyze small samples of blood, but it's hard to constantly monitor blood, Jay explains. Sweat, on the other hand, it's very common, he says. Every day we're sweating.
Thank you. Maria.
Gels,
Yeah.
current sensors needs 10 microliters, just a single drop of sweat, but unless someone is very, very warm, getting even the droplet may be a challenge. One way is to exercise until you break a sweat, he says, but that's not always good for patients. Okay, so Joe needs to make someone sweat. He and his colleagues do this using a method called iontophoresis. It applies a small electrical current to the skin. At first, you might feel an annoying sort of tingle, but after a few seconds, Joe notes you don't feel anything because the current is so small. He knows he tried it.
Good. All right. Ayana?
The current induces the skin to take up a small amount of a drug called pilocarpine, which stimulates the sweat glands. The result, a quick droplet of sweat. Gio and his colleagues published their technique 2 years ago in the Proceedings of the National Academy of Sciences. One Gio gets that precious drop of sweat sensors and the circuit board in the flexible wristband go to work. They monitor everything from body temperature to how much sugar is in the sweat.
One more.
The sensor isn't yet accurate enough to use on sick patients, Gio says, but his team will continue to refine the sensor to detect the secrets in sweat, and some of those secrets might one day help catch killers, even if the victims aren't alive to tell the tale.
Very good. Sweat sleuthing, Gina, can you get that for us?
Can you hear me?
Yes.
Okay. Find a fingerprint on your smartphone screen and you might think it's dirt or old skin cells. In fact, it's mostly sweat. When you take a fingerprint, you can see the swirls and little dots in the swirls. Kamarov says, each dot is a sweat gland hanging on to the tip of the finger. Detectives in TV shows and movies dust for those fingerprints to find a killer. But the fingerprints of victims have tales to tell, too. Tales from their sweat.
Keep going.
David Russell is a chemist at the University of East Anglia in England. During one investigation, police asked him if it was possible to find out if the disease had been poisoned. Russell had been working on a handheld device to detect drugs and fingerprints, including residues of drugs that could kill someone.
One more.
At this point, he'd only tested the device on warm, living hands, not the dead. But Russell had already figured out that the fingerprints were filled with clues.
All right, let's go back to that prior question that we read. Okay, so why is sweat a good substance to monitor when looking for signs of disease? Chris? Is it easier to get? Yeah, so that sweat, we sweat every day, so it's easy to obtain sweat, okay? Or we could potentially sweat every day, especially here in Miami because it's very warm. How does Weigao get people he is studying to produce sweat? And then remember that they mentioned they attached a little device to the hand with produce sweat. And 8, what is the substance that leaves behind the fingerprint on the phone? What's the answer for that? Also, okay, I'm gonna have you guys answer that. That's too easy for you not to be able to answer on your own. Let's get to the next question. How does David Russell's device for detecting drug metabolite? All right, can you read here, please, Lamont, in the sweat?
In the sweat of a fingerprint, we can detect drugs in their
Metabolites.
metabolites, which are breakdown products. When someone takes in any drug, from a painkiller for a headache to an addictive drug such as cocaine, the body breaks down the chemical into pieces, he explains. Most of these pieces come out when the person pees. That's why officials analyze the urine when testing athletes for drug use. But some of those breakdown products also show up in blood. And if it's in the blood, Russell knew it could also end up in sweat.
Okay, again, another paragraph.
Normally, when scientists want to check a sweat sample for drug
metabolites,
they have to take it to a lab. Russell tried another way. He built a small cartridge that takes a sweat from a single fingerprint. Inside the cartridge are antibodies.
Cartridge. It's like a compartment. Cartridge.
Inside the cartridge are antibodies, small chemicals that bind onto specific drug parts. If they don't bind to a drug, they bind to a drug, they bind to a green glowing chemical instead. A lot of glowing green means very little drug is present. Very little color means the fingerprint is full of drug residues. This technique is called
immunofluorescence. Okay, one more.
Investigators wanted Russell's team to find out if this test could detect drug breakdown products in dead people. Do corpses have enough sweat in their fingerprints for this to work?
All right, excellent. All right, so we're going to stop there. I'm going to allow you guys to continue reading and answering the questions on your own. Do you guys have any feedback for anything related to the past assignment or something you'd like to do for future assignments? All right, thank you for joining me. And if you haven't already sent in your work to compete for the contest, please do so, okay? Bye-bye.